Okay, so in this lesson, we're going to look at basic concepts of functions. And before we can talk about the idea of what a function is, which is a very important concept in mathematics, especially in college algebra and calculus and so forth, is the idea of functions. All right, but before we can do that, let's talk about what a relation is. Now, in mathematics, a relation is defined to be a set of ordered pairs. So basically it's how or the coordinates, we're talking about ordered pairs, so how the coordinates of each part of the ordered pair related to each other. So here are some examples of a relation. All right, so some examples would be, um, so the first one would be basically what you think of, a set of ordered pairs. So you have something like this set. And remember, we use this brace to indicate a set. So let's say we had the ordered pair 5, 2. So remember, in terms of ordered pair, we normally talk about the idea of x and y. So the x coordinate's 5. When the x coordinate's 5, my y coordinate is 2. I could have an ordered pair that could be, let's say, 6 and -1. I can have an ordered pair that could be, let's say, 4 and -2, and so on. Okay? So basically, that's an 8. So basically, um, a relation is just a set of ordered pairs. And notice that in this set right here, I have 1, 2, 3, 4. 4 ordered pairs. Okay? So this is a finite set. So this is a finite set of ordered pairs. I'm using the word finite. Finite meaning you can count them versus infinite. So finite set of ordered pairs. Okay, so that's an example of a relation. Another example of relation that you did in this course so far was this. Remember when you graphed lines? So let's say we had in this coordinate plane, we had, let's say, this line here. So a graph So a graph is also a set of ordered pairs, because if you notice this line contains an infinite number of points, and each point represents an ordered pair. Okay? You also graphed, at the beginning, you graphed a basic quadratic function. So let's say we had this parabola that went up like this, that went up. So so remember, all these graphs are relations because they represent a set of ordered pairs. So every point on that graph is an ordered pair. Okay? Number 4, if we look at this graph, now you haven't graphed this kind of situation, but let's say we had this relation right here. So notice that this is also a relation because the graph is made up of a set of ordered pairs. All right. Number 5, let's say we had y equal 2/3 x minus 4. So an equation is also a relation because it represents a set of ordered pairs. So I can represent a relation by using an equation. I can represent a relation by talking about graphs, using the idea of graphs. I can talk about a relation by just using a finite set of ordered pairs. I'm going to put that right here, a finite set of ordered pairs. Now, I want you to remember some of these equations should be obvious to you what graph it is. So for example, you graph this kind of equation, that's a linear equation. So the graph of this would be a line. All right, so the equations represent a set of ordered pairs because if you use a t-table, remember when we use a t-table? If you use a t-table, you can, for each x coordinate, so let's say x is 0, I can substitute 0 into x and I'll get a y value. So 2/3 times 0, 0. 0 minus 4 is a -4. So you see, it's a set of ordered pairs. So in this particular case, this equation, there's really an infinite set of ordered pairs. And remember, when you graph this line, you just graphed either 2 or 3 points. So if x is 3, for example, I can find the y value. So when x is 3, I get y equals 2/3 times 3 minus 4. And then these 3's divide out, so you get 2 minus 4, which is -2. So basically, the point being here is that every equation you've dealt with and even more that you're going to deal with, those are relations. And a relation is just a set of ordered pairs. So you see I can get these ordered pairs here. And there's an infinite number. All right, so you also graph the beginning. I'm not going to spend much time on this, but you also graph something like x squared minus 2. You graph that at the beginning of the course. And so basically you use the t-table. That's what you did. And so you said when x is 0, I get y equal 0 squared minus 2, which is a negative 2. When x is, let's say, I'm making this up, 2, we get y equals 2 squared minus 2, which is 4 minus 2, which is 2, and so on. So all of these equations represent a relation because it's a set of ordered pairs. Okay? So that's basically the idea of a relation. Now what I want to talk about now is the idea of a function. A function. So let's talk about what a function is. All right, so listen carefully to this. All right, so this is something you're going to have to make sure you understand, and it's something you're going to have to make sure you know how to define. So a function is a relation in which for each x coordinate, now remember the set of x coordinates called the domain, there's only one y coordinate, and the set of y coordinates, remember, is called the range. All right, so this is important. In order for a relation to be a function, for each x coordinate, there must be only one y coordinate attached to it. Okay? All right, so for example, let's look at this part. Well, first of all, let's determine what, let's talk about the objective. So the objective is this: determine whether a correspondence or relation is a function. Okay? And then we're also going to, in some of these, we're going to state the domain and range. State the domain and range. All right. So if we look at the first one, so we look at example 1. So example 1, you have your correspondence here. So you have your domain consists of these 4 letters, and your range consists of these 4 letters. All right, so listen carefully to what this correspondence implies. It says this: when my domain is B, for the element B in my domain, it corresponds to just X. See this little arrow? There's only one correspondence. That's important to think about it this way. When my element, I'm using the word element, when the element B in the domain, it is attached to the element X from the range. And notice there's only one arrow, okay? So far, I want you to think about the definition of the function. For each x coordinate, or for each element in the domain, it must be attached to only one y coordinate or one element in the range. Okay? So B is attached to just x. You see that? C is attached to just M. Now remember, you must go from the domain to range, not from range to domain to range, because if you look at the definition of a function, for each x coordinate, see that's listed first, there must be only one y coordinate. So I want you to look at this. When and I'm going to call this x and then this y. So when x is B, there's only one y coordinate, and I guess I shouldn't because we're using the word x here, the letter x. So there's only one y. There's only one element here, right? For this element C, the range, there's only one element attached to it. See, there's only one arrow coming from each element of the domain. So whenever you see that, whenever you see there's only one element attached to an element in the domain, then right away that's a function. So this is a function. This is a function. This is a function because, listen carefully, because for each element of the domain, there is only one element of the range attached to it. Okay? So that's what that says. So for each element of the domain, there's only one element of the range attached to it. So that's the definition of function. And so one of the things I want you to tell me, though, is say the domain and range. So here's how you're going to write the domain. So see how this is a finite set? You can count those. There's 4 elements here, 4 elements here. So you're going to say this. You're going to say domain equals, you can use your set notation, set a little brace. Let me do a little bit better. This brace right here. And all you're going to do is just list your elements. So you're going to say B, C, H, I. All right, so there's your domain. So you make sure you say that. Make sure you say domain equals, and then your brace, and then you just list your elements. If it's listed more than once here, you just list it only once here. Okay? And then the range, let me see if I can find some room here. So the range then would equal, and then you do the same thing, X, M, K, A. So X, M, K, A. And notice that this range consists of just 4 elements. Okay? All right, let's look at this example number 2. So in example number 2, we have this. Now I want you to notice, listen carefully, there are 3 elements here in the domain, and there's only 2 elements in the range. So right away, if you want to go directly to indicating the domain and range, you can. So the domain, you're going to say, will equal 7, 9, and 4. Okay? 7, 9, and 4. So those are the elements in the domain. The range, the elements are 10 and 8, and it doesn't have to be in order. You could say 8, 10, you can say 10, 8. Does not matter. All right. Now let's determine if this relation is a function. So remember the definition of function. Definition of function says for each x coordinate, or for each element in the domain, there's only one y coordinate or one element in the range attached to it. Okay? So what I'm going to do here, sometimes it helps students if they think about this in terms of drawing these arrows. So I want you to think about this. When my element is 7, so the element 7, it is attached to, see this arrow? So there's only one arrow coming from it, right? So it is attached to the element 10 from the range. All right, so far we're good. So far that's a function. We got to check all of it. So when my element is 7, start in the domain, when my element is 7, how many elements from the range are attached to it? Just 1, 10. Do the same thing for 9. When the element 9 from the domain, if you look at it, it is attached to only one element in the range. If you look at 4, 4 is attached to only one element in the range. It doesn't matter. See, it's okay for 10. See how 10, there are 2 elements in the domain attached to it? That's fine. It's still a function. So it's still a function. It is still a function because for each element in the domain, there is only one element of the range attached to it. Okay, so for example, for the element 7, I get the element 10 from the range. For the element 9, I get 8 in the range. For the element 4, I get 10 in the range. So you see, for each element in the domain, there's only one, see there's only one arrow, right? There's only one arrow coming from it. And so that implies that there's only one element in the range attached to it. So that's a function. All right, let's look at number 3. So let's look at number 3. So number 3 is this. So here's number 3. This is number 3. So this is number 3. So right away, if you want to talk about the domain and range, you can. So the domain, see, this is a finite set, so you can count those. There's 1, 2, 3, 4. So we're going to say domain equals the set H, Z, B, C. The range will be the set L, N, P, K. All right? So I stated the domain, I stated the range. All right, now I want you to notice this, and I'm going to go ahead and kind of talk about this here. For H, let's think about how we did this right here. So how we did this right here, I took this part and I kind of rewrote it. So let's kind of rewrite this. So I think it may help you. For H, for the element H in the domain, it is attached to only L in the range. You see that? For Z in the domain, it is only attached to the letter N in the range. For B in the domain, it is only attached to the letter P in the range. For C in the domain, it is attached, you see this? There are two of them, right? It is attached to L and it's also attached to K. So it's attached to L and K. Okay? Now listen carefully. Let's go back to the definition of a function. A function is a relation in which for each x coordinate or for each element of the domain, there's only one element on the range attached to it. So if I look at this relation, and then kind of look at this now, notice that we're fine here, we're fine here, we're fine here, but here's the issue. For the element C in the domain, there's not one element of the range attached to it. There are two. So this relation is not a function. So this relation is not a function. And it's not a function because for C, there are two elements attached to it. The definition says there must only be one element from the range attached to it. Okay? So that's not a function. Let's look at number 4. And I should have had more room here, so I may need another sheet of paper to talk about number 4. So this is going to be number 4. Number 4. So number 4, we have set of the ordered pair 4, 6. We have the ordered pair 7, 3, and we have the ordered pair 5, negative 2. Okay. Now the way that many students prefer to do this, and it helps them to understand, is that they rewrite it using this idea here, using the idea of those arrows. Okay. So for example, oh, and by the way, let's do the domain and range first. So the domain is a set of x coordinates. All right, so if you look at all these ordered pairs, and there's 3 of them. All right, so 3 of them. You have the x coordinate 4, you have the x coordinate negative 7, and you have the x coordinate 5. So remember, the domain is a set of x coordinates. Domain is a set of x coordinates. Okay. And the range is a set of y coordinates. So I have the y coordinates 6, 3, negative 2. All right, and so the range is a set of y coordinates. Okay? All right, now let's talk about whether this relation is a function or not. So we found the domain, we found the range. Let's see if it's a function. So the way that many students prefer to think about this, and it does help, is to use these arrows. So kind of use the idea that correspondence or a mapping. And so if I rewrite this in terms of a correspondence or a mapping, look at what I get. I get when I'm going to call this x, I'm going to call this y. So when x is 4, it gets mapped, I'm using the word mapped, it gets mapped to 6. Okay? When x is negative 7, it gets mapped to 3. When x is 5, it gets mapped to negative 2. So for each of those x coordinates, was there only one y coordinate attached to it? Was there only one arrow coming from it? And the answer is yes. So this relation is a function. This relation is a function. All right, so it does help to think about this in terms of this. Okay? All right, let's get number 5. Number 5, we have this right here. So let me go ahead and rewrite number 5. So let me rewrite number 5 here. So number 5, and I didn't have enough room, so that's why I'm rewriting it. So number 5, you have this relation. You have the set of ordered pairs, 8, 3, 20, -5, 21, 8, 27. All right, and let's first of all talk about the domain and range. So the domain, remember, is a set of x coordinates, and there are 1, 2, 3, 4. So there are 4 sets of ordered pairs here. So I have the x coordinate 8, I have the x coordinate 20, I have the x coordinate 21, and have the x coordinate 20 again. Now remember, don't list it again. Always list it once. All right, so this domain only has 3 elements. Although we have 4 ordered pairs, it only has 3 elements because 20 repeats. Okay, let's go about the range. So only list it once. Only list it once. The range, you have your y coordinates 3, -5, 8, and 7. All right. Now let's see if this is if this relation is a function by using the idea of that correspondence. So x, y. So let's start. When x is 8, it gets mapped to 3, right? When x is 20, it gets mapped to -5. So far it looks good. So for this x coordinate, I only have one y coordinate. For this x coordinate, I only have one y coordinate. When x is 21, it gets mapped to 8. So far so good, right? When x is 20, now be careful. See how we only listed once? Only listed once here, because if you list it again, you're going to mess up probably. I already have it. See, it's already here. So be careful. It's already here. So use this one. When x is 20, it gets mapped to 7. Okay? It gets mapped to 7. All right, so let's think about this. Let's think about this. When for 8, I get 3. For 20, I get 2 arrows coming from it. I get a -5 and a 7. So that means that when x is 20, there are 2 y coordinates. And remember, the definition of function says in order for it to be a function, in order for that relation to be defined as a function, for each x coordinate, there should only be 1 y coordinate. I have 2. So now tell me, is this a relation or, I'm sorry, is this a function or not a function? It is not a function. So it's not a function, since when x is 20, there are 2 y coordinates. There are 2 y coordinates. There must only be 1 y coordinate. For each x, 1 y. For each x, 1 y. So look, for each x, 1 y. 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 When x is 21, there's only 1 y, but the problem is the 20. When x is 20, there are 2 y coordinates. So it's not a function. All right, let's look at number 6. Number 6 is this one. So we go ahead and write off number 6. So number 6, we have this. We have the set -3, 4, 8, 7, 5, 4, and 0, 4. Oops, 0, 4. All right, and so let's go ahead and talk about the domain. So the domain is a set of x coordinates. So it'll be -3, 8, 5, and 0, right? And the range is the set of y coordinates. So 4, 7. I already have 4 listed, so don't do it again. You already have it listed once. Only list it once. And then 4 again. So 4 is listed 1, 2, 3 times, right? So this domain only has 4 elements in it, and the range only has 2 elements in it. So we want to determine now if this is a function. So it really helps if you use the idea of a correspondence or mapping to help you. So for example, let's just call it x and let's call this y. So when x is -3, and you just go in order. When x is -3, I get the y value 4. Okay? When x is 8, I get the y value 7. When x is 5, I get the y value 4. Don't do it again. It's already listed, so just draw an arrow going to this. When x is 0, I get the y value 4 also. So still, for some students, this confuses them. This really confuses them for some students because they see these all these arrows pointing towards one number. And so it does confuse some students in terms of determining whether this is a function or not. So if it does, then let's rewrite it. Let's do this way then. For -3, I get one y value, right? For 8, I get one y value, correct? For 5, I get one y value. You agree? For 0, I get one y value. So these two are the same thing. So notice that for each of those x coordinates, how many arrows are coming from them? See, one arrow, one arrow, one arrow, one arrow. That's what this says. One arrow, so when x is -3, it's 4. When x is 8, there's only one y value, it's 7. When x is 5, there's only one y value, it's 4. When x is 0, there's only one y value, it's 4. It doesn't matter that these y values repeat. It's what happens here. For each x, there's got to be just one y. Okay? So this is a function. So this is a function. All right, it's a function because for each x coordinate, there's only one y coordinate attached to it. There's only one y coordinate attached to it. Okay? All right, so that's number 6. All right, let's look at number 7. All right, so this is number 7. I'm going to go ahead and rewrite number 7. So number 7, we have this. We have C equals, so C is going to be our set. So this set is called C. So again, it's still a set of ordered pairs. We have -3, 4. Sometimes in your problems, instead of just listing the set like we did here, they'll give it a name. So in this problem, in number 7, the name of this set is set C. So sometimes you'll see that. 3, 9, 4, 3, 5, 9. And that's not the idea that this set is called C is not important here. All you do is just look at this. So the domain, let's do the domain again. Domain is your set of x coordinates. So it's -3, -3, 3, 4, and 5. Okay? Your range is a set of y coordinates. 4, 9, 3. 9's already listed. 9's already listed, so don't list it again. So your range only has 3 elements. Again, don't list it again. You only list it once. Now let's talk about if this is if this relation is a function or not. So let's call these x and y. So when x is -3, I get a y value of 4. So just one error so far, right? But you got to check all of them. When x is 3, I get a y value of 9. So far we're good. When x is 4, I get a y value of 3. So far we're good. When x is 5, I get a y value of 9. We're good, right? For each of those x coordinates, how many arrows are coming from it? Just one. So it doesn't matter that 3 and 5 have the same y coordinate. That doesn't matter. It doesn't matter. As long as for each of those x coordinates, there's only one arrow coming from it. So therefore, this is a function. Okay? All right, let's look at number 8. Number 8, it looks like this now. And that number 8 should be easy for you because we talked about this idea. So sometimes it'll be given in terms of a t-table. So we have this. And I want you to think about this. All right. So first of all, the domain is going to equal. You have 4 elements. Oops, sorry, 3 elements here, right? 3 distinct elements. 4, 7, 6. 4 is listed twice. You only list it once. The range will be -8, 3, 2, 5. So remember, the range is a set of y coordinates. Now, what I want you to notice is this. All right, now be careful. Because some students see this. They see 4 to -8. That's one arrow, one arrow, one arrow, one arrow. But you got to be careful. That's why it's not always a good idea to think like this. So what I want you to do is this. When x is 4, I get -8, right? When x is 7, I get 3, right? Okay. When x is 6, I get 2, right? So far it looks good. So far we have a function, right? One arrow, one arrow, one arrow. When x is 4 again, so that's why I told you only listed once. See those 3 elements? That's this right here. So don't put any more down. When x is 4, that's this right here. So when x is 4, it gets mapped to 5. And so now notice, you see those 3 elements correspond to these 3. Those 4 right here corresponds to those 4. Notice that when x is 4, there are 2 y coordinates. When x is 4, there are 2 y coordinates. The definition of function says there's got to be just 1 y coordinate. So this is not a function. All right, so that is not a function. Okay, now let's look at number 10. So number 10, sometimes it will be given in terms of an equation. Now I want you to think about this. If the ordered pairs, if a set of ordered pairs is given, many students can handle that. They can look at this, kind of rationalize through this, and determine if it's a function or not. Sometimes an equation throws them off. Now for us right now in this objective, the equations will be fairly simple to deal with. What I want you to notice is this. You graphed this at the beginning of the course. This is a linear equation. And to graph a linear equation, at first we use a t-table, right? And so basically when x is 0, I get y equals 3 times 0 minus 1. So it's 0 minus 1, which is -1. So when x is 0, there's only one y value. And then what you did was you graphed this line. And so you graph something that looks like this. So 0, -1 is right here. Then let's say if x is 2, I get y equals 3 times 2 minus 1. So that's 6 minus 1, which is 5. Right? So then you apply the 0.25. 1, 2, 1, 2, 3, 4, 5. And then you did maybe another one. Let's say you did -2 instead. So when you let x be -2, you got y equals 3 times -2 minus 5. So 3 times a -2 is a -6. A -6 and a -1 is a -7. So you apply the point -2, 7. So 1, 2, 1, 2, 3, 4, 5, 6, 7. So you got something like this, right? And then you drew your line. And basically, I want you to look at this t-table. Now, this we're going to come back to in a little while. But I want you to look at the t-table. Think about this. For each x you placed on the left side, how many y values were there? That was just 1. When x is 0, you're going to get 1 y value. When x is 2, you're going to get 1 y value. When x is -2, you're going to get 1 y value. And so this equation, this linear equation is a function. This is a function. Okay, so this linear equation is a function. And I want you to think about this. Whenever a graph is given, in a little while we're going to learn something called the vertical line test. So we're going to come back to this in a little while. But what I want you to notice is that this particular linear equation is a function, because for each of those x coordinates, it looks like I'm going to get 1 y coordinate. You may say, well, can we do another one? Sure you can. Let x be 8. 3 times 8, notice up here, 3 times 8 is 24. 24 minus 1 is 23. You get no other y coordinate for 8. It is just 23. Okay? And you can continue on. So in this case, when the equation is given, you see the graph, there's an infinite number of points. All right? Let's look at another one that you did. Another one that you did real quick was something like this. Y equals x squared minus, let's say, 2. You did that earlier. Y equals x squared minus 2. Beginning of the year, beginning of the semester. So basically what you did was use the t-table again. use a t-table again. And so you said, all right, if x is 0, I get y equals 0 squared minus 2. 0 squared is 0. 0 minus 2 is a negative 2, right? When x is 1, you got y equal 1 squared minus 2. So 1 squared is 1. 1 minus 2 is a negative 1. So you see, for each x coordinate, you're getting one y value. When x is, let's say, negative 2, let's see what happens. Negative 2, you got y equal negative 2 squared minus 2. So we saw the variable x, you substitute negative 2. So I get negative 2 squared is 4. 4 minus 2 is 2. So for each of those x coordinates, you had just one y value. And so let's say x is positive 2. Positive 2. So x is positive 2, you got y equal 2 squared minus 2. So that's 4 minus 2, which is 2. So I want you to notice, see that y value is the same, right? But it doesn't matter. It doesn't matter that you get the same y value. When x is negative 2, there's only one y value. When x is positive 2, there's only one y value. So that's a function. And I want you to remind you what the graph looked like. So when you graph this at the beginning of the semester, you have 0, negative 2. You have, oh, that's 0, negative 2 here, sorry. 0, negative 2. You have 1, negative 1. You have negative 2, 2. And you have 2, 2. And so your graph was this parabola. Remember that? You had this parabola. All right, and so notice that this parabola, there's an infinite number of points, so you could go on and on forever for this. But basically, this is a function. So this quadratic equation is a function. So basically, if the equation is given, you can easily determine if it's a function by just plotting some points, finding some points, and seeing if for each x coordinate, there's only one y coordinate. Okay? Now, I want to look at number 12. Number 12. In number 12, you had this. You had something like, let's say, x minus 2 squared plus y plus 1 squared equal, let's say, 9. Now, remember, you had this before, so you have this equation. It's not as simple. It is not as simple as number 10 and 11, but you had this before, and I want you to notice something. This is a circle. Remember that? That's a circle. That's the equation of a circle. The center is 2, negative 1, and the radius is the square root of this number. So the square root of 9 is 3. And so when you graph this, you had the circle, the center, 2, negative 1. So there's a center. And so from the center, you went 3 units up. 1, 2, 3. 3 units down. 1, 2, 3. It's not scaled right. And then 3 units to the right. 1, 2, 3. And then 3 units left. 1, 2, 3. And then you just graphed it. You graphed it something like this. Again, it's not scaled right. But here's the idea. And this is hard for students unless they look at the graph. This is not a function. This right here is not a function. So let me explain why this is not a function. Okay, so this is not a function. Let's go back to our graphs. And I'm going to use a ruler to help with this. Notice that for when x was 0, we got a y value negative 1, correct? And so that means this. So when x is 0, meaning right here, when x is 0, this ruler crosses the graph only once. So that means that for this x value, there's only one y value. For this x value 1, when x is 1, there's only one y value right here. When x is 2, there's only one y value right here. All right. So notice that in terms of a graph, you can easily determine if a graph represents a function by using that idea of that ruler. So notice this ruler only intersects the graph only once. So this ruler intersects the graph here, which means that for this x coordinate, there's only one y coordinate. For this x coordinate, there's only one y coordinate. Okay? So let's talk about this a little bit further. It's not a difficult concept for students. Most students can handle this. Okay, so I want to talk about this in terms of this line also. So I want to take the ruler, okay? So basically the direction is going to say something like this: determine if this relation is a function. So I want you to notice if I take this ruler, and no matter where I put this ruler, it intersects the graph just once. You see that? Y'all agree? It only intersects it just once, just like this. So what that means is this. I wanted to look at -2. When x is -2, right here, there's only one y value. That's what that means. That's how I want you to think about this. When x is -2, there's only one y value. When x is -4, there's only one y value, whatever that y value is right here. That's what that means. When x is +4, there's only one y value right here, whatever that y value is, -2. So when x is -5, it intersects the graph here, right? When x is -5, it intersects the graph here. That means there's only one y value. When x is 3.7, right here, there's only one y value. So listen to my words now. When we use this ruler to help us determine if a graph is a function, we're asking ourselves, how many times does the ruler intersect the graph? So for this x value, just once. For this x value, just once. For this x value, just once. Isn't that the definition of a function? For each x coordinate, there's only one y coordinate. For each x coordinate, there for each x coordinate, there is only one y coordinate attached to it, right? What I just used here is the idea that vertical line test, a vertical line test. So we're going to talk about the vertical line test. So basically the vertical line test says this. The vertical line test says this. So we can use the vertical line test to determine if a relation is a function. Okay, so basically, if I look at this graph, this problem, and I look at this ruler, I use this ruler, notice that for when x is 1, there's only one y value. It is 4. When x is 2, there's only one y value right here, whatever this y value is. When x is 3, there's only one y value, 0, and so on. So notice that this graph passes the vertical line test. It passes the vertical line test, meaning that for each x coordinate, there's only one y coordinate. For each x coordinate, if x is 5.6, let's say, there's only one y coordinate. Okay, it intersects the graph once everywhere. So this is a function as well. So the vertical line test, we can use the vertical line test to determine if a relation is a function. And basically, if the vertical line intersects the graph just once everywhere, graph once everywhere in the domain, then it is a function. Then the relation is a function. Okay, so then the relation is a function. Now I'm going to go back here, and then I'm going to use the idea of that vertical line test. So I'm going to use a red marker. So basically, watch. If I draw a vertical line, how many times did it intersect it? Intersected once. So that means that for this x coordinate, there's just one y coordinate. Same thing here. Intersected once, everywhere. That's what I'm saying. Everywhere. Okay. Same thing when I went to this parabola. I can use a vertical line test. So if the graph is given, it's easy to determine. Just think about that vertical line test. No matter where I draw that vertical line, it intersects it once, meaning that for each of those x coordinates, there was just one y coordinate attached to it. Okay. Now, let's look at this one. What do you think about this one? Is this a function or not? It's not a function, right? Because if you look at when x is negative 3, when x is negative 3, there are two y values. There's this y value, 0, and then there's this y value, 4. So notice that this vertical line intersects the graph here twice, in fact, in an infinite number of places. So this is not a function. So this right here is not a function, not a function. It fails the vertical line test. It fails the vertical line test. Now, meaning this, remember our discussion, when x is negative 3, how many y values were there? There are 2. When x is, whatever when x is negative 2, there are 2 y values, whatever these y values are. So this y value and this y value. All right, so see, it fails the vertical line test. So that's not a function. And one other thing that you may see, and I just want to mention to you, is that you see these graphs right here? Those graphs, those three graphs I just showed you, consists of an infinite number of points. Okay? Consists of an infinite number of points. This graph here consisted of an infinite number of points. This graph here consisted of an infinite number of points. It is possible in some of your problems where you will have a finite set of ordered pairs. So for example, you could see this. Okay, look. You could see this point here. So this ordered pair. You could see this ordered pair. So remember, this is your graph. So you could see a graph that has these ordered pairs, just like this. Okay? Just like this. So this graph has a finite set of ordered pairs. So you see how an infinite set of how these graphs had an infinite set of ordered pairs and they were connected. These are not connected. So this graph only has 1, 2, 3, 4, 5, 6. So this graph has 6 ordered pairs. My question to you is this. Use the vertical line test. Use the vertical line test to determine if this is a function. If this relation is a function. All right, so here's what you do. So see this little point? Let's start with the first one. When it only intersects the graph once, right? It only intersects this point once. So when x is negative 8, there's only one y value. What is it? Negative 2. When x is negative 6, there's only one y value, positive 2. When x is negative 4, there's only one y value, 5. When x is 1, there's only one y value, 3. When x is 3, there's only one y value, that was 7. When x is 5, there's only one y value, 1. Okay? So it passes the vertical line test. So it's a function. Okay? Now what about this one? We're going to do one more, and then we're going to end this part of our lesson on the basic ideas of functions. Okay, now watch this one. What if you had this? Let's say you had this point, you had this point, you had this point, you had this point, and let's say this, and let's do this. Okay? All right, so I have 1, 2, 3, 4, 5, 6 again. So I have 6 points. And so notice that's a finite set. They're not connected. Okay? It's just a finite set. So my question to you is, let's use a vertical line test. Use a vertical line test to determine if this is a function, if this relation is a function. Is a function. So when x is negative 8, how many y values do you have? Just one. It is 2. When x is negative 5, how many y values do you have? It is just one. It is 5. When x is negative 2, you have one y value. So basically, this is what you're saying, right? So watch. You're saying, if you do the x and y again, you're saying when x is negative 8, you get a y value of 2. You agree? When x is negative 5, you get a y value of 5. Just like you were doing previously. When x is negative 2, you get a y value of 4. When x is 2, be careful. Look at your ruler. Look at your ruler. It intersects it twice. For this x value, it intersects the graph twice. You see that? What that means is this. When x is 2, there are two y values. There's a y value of -3, and there's a y value of 6. So this right here makes this not a function. So it fails the vertical line test here. I'm going to draw the red line. See, it fails it here. It intersects the graph twice. When x is 2, it intersected the graph twice. So this relation is not a function. This relation is not a function since when x equals 2, there are two y values. There are two y values. So remember, the definition of function says that there must be only one y value. Okay? All right. So, oh, by the way, if they ask you to state the domain and range for that one, since that's a finite set, it's easy to do. You just state the x values. So -8. So -8 is one of them. The other one would be -5. The other one would be -2. The other would be a +2. Although there are two y values, you still say +2. And then the other one is, what's that, 5? And then the range would be, and you got to look at the y value now. So for this point, the y value is 2. For this point, the y value is 5. So I'm putting a 5 here. For this point, the y value is 4. For this point here, the y value is -3. For this point here, the y value is 6. For this point here, the y value is 5, but I already have it listed. Okay, so I'll list it again. So there, and just take this comma off. And so there's your domain and range. But again, this is still not a function. It's not a function because they failed the vertical line test here when x was 2. So there are two y values. There are two y values for when x is 2. Okay? All right, so that's going to take care quite a bit of stuff here. Oh, and I'm sorry, I forgot to talk about the circle. Excuse me. So this equation of a circle. So when you have a circle, is that a function? Right away, you're going to say what? No, because it fails the vertical line test. So this is not a function. It fails the vertical line test. I forgot about number 12. It fails the vertical line test. And number 11, you can now say, remember, it's a function. We saw it using a t-table, but you can also use the vertical line test. So the vertical line test, it intersects the graph once everywhere, so it is a function. Okay? So another one that you had, by the way, another one that you had to graph earlier was absolute values. So if you notice, is this absolute value a function? Yes. So this is a function. It passes the vertical line test. This right here, that's not a function because it fails the vertical line test in this area here. You see that? So it intersects it more than once. So this is not a function. It fails the vertical line test. All right. So that's basically the idea of using a vertical line test on a graph to determine its function. Now, it's very easy to do. It's just got to cross the vertical. It's got to cross the graph once everywhere. See right here, it crossed it once here, right? But it didn't cross it once here. Look, 1, 2, 3, 1, 2, 3, and so on. Okay? All right, so I think I am done talking about the idea of a function. So basically what we did was we determined whether a correspondence relation was a function, and in many of the cases, we went ahead and talked about what the domain and range is. Okay, so that's going to be the end of this lesson.